7.4, we're going to be adding and subtracting polynomials. So in this section, it's all about fractions. Yay. So when adding or subtracting with like denominators, all we have to do is keep the denominator the same and just add the numerator. Same thing with subtraction. Just keep in mind that with subtraction, the minus applies to everything after it. So we have to distribute it before we combine our like terms together. So just keep that in mind with subtraction, which we'll see. When it's only one term, you don't really need to worry about it. But if we had two terms behind it, we would need to worry. So in adding or subtracting, we need like denominators. So example 1. A, we have like denominators, so our denominator stays the same. Then we just add our numerators together. What's 7 plus 3? 10. Can we simplify 10 over 4x? Awesome. 5 over 2x. So let's look at B. Our denominators are the same, so we keep it the same. And then we just subtract our numerators. Can we combine 2x minus 5? No, they're not like terms, so it would just be 2x minus 5. And that's it. So they asked, why can't we simplify 2x and 6? Because 2x is part of this, and 6 is part of this. So it's all one thing. Unless it was a number that's being multiplied, we can't simplify it.
So,
this is 7.4, right?
But so A is being multiplied here, so we can simplify that. B is not. If we had, let's say, 2 times x minus 1 over 2, this is being multiplied, so we could cancel these out. But if we just had 2x minus 1 over 2, we can't cancel these out because this is all one piece.
oh, okay.
Any other questions on this one? All right, next page, number 1. So our denominators are the same, so that 12x stays the same in our denominator. And then we subtract our numerators. So what's 8 minus 5? 3. Can we simplify this? What does it simplify to? 1 over 4x. Perfect. All right, number 2. Bless you. What's our denominator? 3x squared. And what's our numerator? 3. Can we simplify this? What does it simplify to? 1 over x squared. Awesome. Number 3. What's our denominator? X minus 2. What's our numerator? Awesome. 3x. So these are like terms, so it's just 4x minus x. So we can combine them. Can we simplify this?
No.
No, we cannot. Because this x minus 2 is together. So those x's don't just cross out. Can't do that. All right, and number 4. What's our denominator?
x2 plus 1.
X squared plus 1. What is our numerator?
x2. Oh no, 4x2.
2x squared plus 2. We can't combine these together because they're not like terms. So this 2 doesn't have an x squared, so can't combine them. So it's just 2x squared plus 2. Do you see anything special about this that maybe we can simplify it a little bit?
You can divide them.
We don't want to
combine them.
divide them. Do we have anything in common on the top that we could take out? The 2?
The 2.
And when we take out the 2, what are we left with?
x2 and x.
X squared plus?
Or 1.
1. Awesome.
1.
And on the bottom we have x squared plus 1. So anything cancel?
X squared plus 1.
X squared plus 1.
No.
He's left with 2.
So we're just left with 2.
And then that's the answer.
And that's our answer.
On this Carver, the lesson's still not on my canvas or anything.
So it's x squared plus 1 because we're dividing both of these by 2. So we take out the 2, so it's just x squared. And then what's 2 divided by 2? 1. So that's where that 1 comes from. So 2x squared plus 2.
And you divided it by 2.
Yeah, this is together, so we wouldn't just be able to cancel out the x squareds. Can't do that.
Okay.
But we can divide out the 2, and then we see we have the same thing here and the same thing here. And remember, anytime we cancel out, we want to state our restriction. So we have x squared plus 1 does not equal 0. What do we do to solve for x? Subtract 1. So x squared does not equal negative 1. Then what do we do? Square root. What happens when we take the square root of a negative? It becomes an I, which is an imaginary number. And whenever we get an imaginary number, we don't have to state the restriction because it's not a real number. And we're not dealing with imaginary numbers right now. So because this is an imaginary number, not a real number, we're never going to get x to equal 0. We're never going to get 0 in the denominator because we're not dealing with imaginary numbers. So this is our answer. We have no restrictions here. So now we're going to look at what to do when we don't start with like denominators. So whenever we have two denominators that are different, we have to find the least common denominator, which is the least common multiple of the two denominators. So if we have a over c plus b over d, we multiply the top and the bottom here by d and the top and the bottom here by c. So that way it gives us a common denominator, which would be c times d. If we had 1/2 plus 1/3, how would we add these together? How can we get a common denominator?
Well, you get 6 and then multiply.
Wait, you have to multiply them?
What do we multiply by 1/2 to get our denominator to be 6? 3. And then what do we have to multiply by the second one to get the denominator to be 6? 2.
2.
So on the first fraction, we would have 3 over 6 plus 2 over 6. Now that we have common denominators, we keep our denominator the same and just add the numerators. So this would be 5 over 6. So we're doing the same thing here, but just with polynomials. All right, so to do another example, let's say we had 1/4 plus 1/6. To find the least common denominator, we know that this is 12 because both 4 and 6 go into 12. So we would multiply 4 by whatever it takes to get 4 to be 12. So this would be 3. We got to do the same for the top and bottom. And then we would multiply 6 by whatever it takes to get 6 to be 12. So this would be 2 and 2. So on the top here, we have 3 over 12 plus 2 over 12, and this would give us 5 over 12. Another way we can look at how to find the least common multiple, we said we have, well, we're just looking at the denominators now. So if we have 4 and 6, we're finding the least common multiple between 4 and 6. Our multiples, our factors of 4 are 2 and 2. Our factors of 6 are 2 and 3. So to find our least common multiple, we don't include something if it is in common between the two. So we have a 2 in the 4 and a 2 in the 6. So we only want to put one of those 2's here. But we need to put everything else that's not shared. So we have 2, times 2, because these 2 turn into 1, 2, times 3. So 2 times 2 times 3 would give us 12. So that is another way of looking at the least common multiple. We did the same thing here with our denominator. It's just going to get a little more tricky when doing it with polynomials. Alright, so here we want to find the least common multiple between these two polynomials. So first we have 4x squared minus 16. We want to take out the greatest common factor of both of them so we see what's in common. We can divide out a 4 in both of these. So 4x squared divided by 4 would just leave us with x squared, and 16 divided by 4 is just 4. So then we can factor x squared minus 4 into x plus 2 and x minus 2. So this is as factored as we can go here. We could actually write down the factors of 4 here as 2 and 2, because that'll help us when finding the least common multiple. We're going to do the same thing for our next polynomial. So we see that we can divide all of these by 6. So we take out a 6. We have x squared minus 24 divided by 6 is 4. 24 divided by 6 is 4. And then we can factor this, our two factors of 4 that add to negative 4 or negative 2 and negative 2. So x minus 2 times x minus 2. And then our factors of 6 are 2 and 3. So first thing we want to do is take our numbers and find our least common multiple between the two. So we said that we just did this example in the last one. 2 and 2 overlap, so we're only going to write that one once. And then we have another 2 and a 3. Now with our polynomials, we have x minus 2 and x minus 2 that overlap. So we're only going to write that once, but we have this x plus 2 and x minus 2, but we only write it once. But we have this other x minus 2 that doesn't have a pair, so we have to include that as well. So we have 2 times 2 times 3 would be 12 times x plus 2 times x minus 2. We could either write squared or write it again. Doesn't matter, same thing. It's just x minus 2 times x minus 2. Okay, I'm going to show you two different ways of solving this one. So two different ways we can add them together. The first way is by finding the least common multiple of the two. So our multiples of 9x squared, all of our factors are 3 and 3 and x and x. So 3 times x gives us 9x squared. We want to factor this 3x squared plus 3x. So we take out a 3x because that's what's in common. And then we're left with x plus 1 because we're just dividing 3x by both of these. So what we have in common between the two is a 3 and an x. So we are only going to write those once. We have a 3 and an x, and an x. We already wrote these for this one, so we're good there. And then we have x plus 1. Now this is going to be our least common denominator, so it's the denominator of our fraction. We can multiply everything together, so 3 times 3 is 9, x times x is x squared, times x plus 1. Now we want to multiply the top and bottom of our fractions here by whatever is missing from this here. So here we have 3 times x times x, 3 times x times x. So the only thing missing is this x plus 1. So we're going to multiply the top by x plus 1 and the bottom by x plus 1. For our second fraction, we have 3x that I crossed out. So 3x, I'm going to change color. 3 and x, 3 and x. x, and then x plus 1. So the only thing we're missing is 3 and x. So we're going to multiply both of these by 3x. Now when multiplying 7 times x plus 1, we have to make sure we distribute. So this would be 7 times x, which is 7x, and 7 times 1, which is 7. And then here we have x times 3x, which would be plus 3x squared. And then we see on the denominators here, by multiplying 9x squared by x plus 1, we're turning it into this. By multiplying 3x times 3x squared plus 3x, we're turning it into this. So that's how we have to get our denominators to be the same. We can rewrite this in standard form. So we start with our highest degree. So we have 3x squared plus 7x plus 7 over 9x squared plus, times x plus 1. So that's one way of solving it, the least common multiple way. Another way we can solve it is just multiplying the whole thing by the denominator of the other one. So I'm going to rewrite the problem, and I'll show you what I'm talking about. So we have 7 over 9x squared, that is a squared, plus x over 3x squared plus 3x. So we are going to multiply the left fraction by the right denominator. So we have 3x squared plus 3x over 3x squared plus 3x. And then we're going to multiply the right fraction by the right denominator. So times 9x squared times 9x squared. So now our denominator is this. So we have 9x squared times 3x squared plus 3x. And then on top, I have to distribute the 7 to both things on the inside. So this would be 21x squared plus 21x plus 9x cubed. Now I just want to simplify to make sure I can't cancel anything out. So out of the top, I know I can take out a 3 and an x. I'm taking out 3x. So divide everything here by 3x. So I have 7x plus 7, just 7, and then plus 3x squared. Now I'll rewrite this in standard form in a second. Out of the denominator, I can divide out a 3x here. So I have 9x squared times 3x times x plus 1. Now I can multiply this 3x into the 9x squared. Or I can just cancel the 3x and the 3x before I even multiplied it. Because those are what's in common. We're multiplying, so I can cancel them out. So on top I have 7. I'm going to write it in standard form. So this would be 3x squared plus 7x plus 7 over 9x squared times x plus 1. So number 6. We want to find our common denominator between the two. So we're just going to multiply 4x times 7, and that's going to be our denominator. So what's 4x times 7? X.
28x.
So we multiply the top and the bottom here by the other denominator. So we multiply the top and the bottom by 7. and then we multiply the top and the bottom here by 4x. Because that'll give us 28x here, and it'll give us 28x here. So then we want to multiply the top here. So 7 times 3 is 21. And then we multiply the top here.
4x.
4x. So it is 21 minus 4x. Do we have anything in common here that we could take out? No.
7 and 4. Oh.
7 and 4 aren't like common multiples. So like we can't divide 21 by 4, or we can't even divide it by 2. We don't have anything in common that we can pull out from these two numbers. So I'm just going to rewrite this in standard form. So this would be negative 4x plus 21 over 28x. And that is our final answer. Can't simplify this anymore because these two terms are stuck together. So you can't just cancel out the x's. Doesn't work that way.